Hi everyone, I hope you're okay. This is video number 4, guys, from me answering the November 2023 Physical Science Paper 2 exam. Uh, since I'm doing video number 4, it simply means there are 3 videos before this one. You can just click the link on the description. It will take you straight to the playlist whereby I answer the first 3 questions, and there is another playlist, by the way, guys. Excuse me, whereby I tackled physical science paper 1. It's the November 2023 question paper as well, and I did the same thing for maths for maths paper 1 and paper 2. So you can just visit the channel and just click any playlist you would want to watch. Okay. Question 4. Before you even start, guys, please don't forget to subscribe. Your subscriptions are very, very important. They help us grow the channel, and maybe you can reach a lot of learners before they write their final examination. Okay. Question 4. Ne? We are supposed to consider the cracking reaction that takes place here. Ne? By definition, what is cracking? Cracking is a chemical process of breaking down long chain hydrocarbons into smaller chain hydrocarbons. Are we together? So in this case, they've broken down this long chain hydrocarbon into these 3 small chain hydrocarbons. Are we together? Whenever you break down the hydrocarbons, you must form an alkane and at least one alkene. Are you together? So in this case, I already have an alkane over here. That means these two have to be alkenes. Okay. Since they're alkenes, I know that the general formula for alkene simply says CnH2n. Are you together? So in this case, since I know that I have a 6 there, it simply means that the value of x has to be 12. So that I'll have C6H12. Are you together? So to answer the question 4.2, I know that x has to be 12. X has to be 12 rather. Okay. Now let's go and find y and z. How can we find y and z? Remember that we were given 16 carbons initially. Already we have counted 12 of them on the right hand side. That means the other 4 are here. Are you together? But remember that for this compound we have a stoichiometric coefficient. Are you together? So if for us to have 4 carbons in total, that means we must have C2, because there's a 2 there in front, because we'll just multiply these 2 for us to count to 4. Are you together? So since I have C2, that means my hydrogens, I must have 4 of them over there. Since my subscript is 2, that means my subscript here has to be 4, because I need to respect this thing. Are you together? So whenever you count your carbons and hydrogens both on the left hand side and the right hand side, you will see that they are balanced now. So the value of y is 2 and the value of z is 4. Okay. Then now we are told that compound C6H14, this is a hexane. It undergoes complete combustion. For complete combustion, guys, let me write the reaction here. You must have an alkane there, C6H14. You always add it with an oxygen. It will always produce carbon dioxide and water. Are you together? Then the only thing that we need to do is to just balance this equation. We have 6 carbons on the left hand side. On the other side we have 1, so we just need to multiply that by 6. We have 14 hydrogens. On the other side we have 2, so we just need to multiply by 7. Why? Because 2 times 7 will give us the 14. Are you together? And then now we need to balance the number of oxygens. On the left hand side we have this has 12 oxygens and we have 7. 7 plus 12 is 19. Are you together? And then on the other side we have 2. So since the number that we have on the right hand side is not an even number, we need to write it as a fraction. We'll write it as, let me write it in blue, as 19 all over 2. Then for us to fully balance the chemical reaction, we just need to multiply everything by 2. Are we together? So whenever I multiply my hexane by 2, I'll simply have 2C6H14 plus 19 oxygens will give me 12 CO2 plus 14 H2O. Now if you can count, the number of carbons on the left hand side will be the same as the number of carbons on the right hand side, even with hydrogens and oxygens. Whatever number you have on the left, it will be the same number on the right hand side. So this is the balanced reaction of the complete combustion of hexane. So this is how we will write it. Simply say we have 2C6H14 plus 19O2. This will give us 12 CO2 plus 14 waters. Okay, and then now 4.2. 4.2, we are supposed to consider the reaction, the reactions 1 to 3. Ne? Okay, in reaction 1 we have an alkene. This is an unsaturated hydrocarbon. Why am I saying it's an alkene? Because that the part that I just circled there has one H, and then I have one H. But I know that my carbon, okay, it's bonded with the long chain there. I know that in here my carbon has to be bonded 4 times. Are you together? So since I have one hydrogen for both, that means the double bond has to be there. Are you together? So now the number of bonds in each carbon, I have 1, 2, 3, 4. 1, 2, 3, 4. Are you together? So I have an alkene over there. I have an alkene plus my hydrochloric acid. Okay, this is an addition reaction. Are you together? I will have 2 products, which simply means I'll have a minor product and a major product. Are we together? So my minor product, remember that, guys, whenever we add, we always use the Markovnikov's rule. Ne? The hydrogen will be bonded with the carbon with the highest number of hydrogens. Ne? But in this case, the carbons have the same number of hydrogens. So my major product will be C. How many carbons do we have in the parent chain? 1, 2, 3, 4, 5. Okay, I have 5 carbons in the parent chain. So my major product will have a halogen closer to the terminal end. Are you together? So this will be compound A, and then compound B will just look like this. The halogen will be here. Are you together? So whenever there's addition reaction, most of the time you will have 2 products. You'll have a major product and a minor product. This one is the major product, and then compound B is the minor product. Okay, let's work. The first question says define a positional isomer. Okay, positional isomers. Ne? Positional isomers are organic compounds that have the same molecular formula, but they have they have different positions of either the functional group is positioned on a different carbon, or the side chain is positioned on a different carbon on our parent chain. Are you together? So in this case, for example, these 2 products, the major products and the minor products, both of them are positional isomers. Why are they positional isomers? Because the functional groups positioned in different carbons on the parent chain. Are you together? Okay. They want us to write the type of reaction represented by reaction 1. As I just said, we have an unsaturated hydrocarbon. We are adding a hydrochloric acid or HCl. This type of reaction that will happen is an addition reaction. If you want to be specific, you can say it's a hydrohalogenation. Are you together? Let me just write addition or hydrohalogenation. Okay, and then 4.2.3, they want us to write the structural formula of compound B. Remember that I said compound B is our minor product, right? So compound B will be like this. I'll have 1, 2, 3, 4, 5, and I'll have my 1, 2, 3, 4, 5. I'll have my hydrogen there. And then I'll have my chlorine over here. So this will be my major product, right? And then now 4.2.4, they want me to find the formula of X. What happens in reaction 2? They're taking compound A, and compound A, they are reacting with water, and there's a presence of mild heat there. Remember that compound A, guys, is our major product. So compound A is this one, is our 1, 2, 3, 4, 5, is our 2-chloropentane. All right, together is our 2-chloropentane. So they are taking our 2-chloropentane, they are reacting with water, and then we end up having an alcohol. So what's happening here, guys? This is a substitution reaction whereby you are replacing a halogen with the hydroxide ion. Are you together? This type of a reaction is called hydrolysis. Né? So since we are replacing the halogen with the OH ions, that means we will form as a formula X will be our hydrochloric acid or HCl. Are you together? And then now they want us to write the inorganic reagent present in reaction 3. We can see that in reaction 3 we are moving from alcohol to this alkene that we had over there in reaction 1. Are you together? So what happens in reaction 3? We have an elimination reaction, and we are eliminating water, so we need a dehydrating agent. So this type of a reaction, we will need a concentrated sulfuric acid. It will act as a dehydrating agent. It will eliminate the water on the organic compound. Okay, and then now we are told that compound A can be converted directly to the organic product of reaction 3. Compound A, okay, the 2-chloropentane can be changed into the alkene that we have there. Né? Firstly, but besides heat, write down other reaction condition needed for this reaction. Whenever you remove this type of reaction, guys, is elimination. Né? And the condition reaction for elimination, you need a dilute you need a concentrated strong base. Are you together? And your strong base can be a potassium hydroxide, what else? Sodium hydroxide or lithium hydroxide. Are you together? please note that they have to be concentrated because you are eliminating, né? So it can be KOH, potassium hydroxide, or sodium hydroxide, or lithium hydroxide. Any of the three, but they have to be excuse me, they have to be concentrated. And then 4.2.7, they want us to write down two terms that describe this type of reaction. Firstly, we are eliminating here. Are we together? We are eliminating. What are we eliminating? We are eliminating a hydrogen and the halogen there. So we'll simply say, firstly is elimination. Secondly, we can write it as dehydrohalogenation. Excuse my handwriting. Yeah, but that's how, guys, we could have tackled question 4. I really hope that, guys, it helped, and the videos will keep uploading and helping you out. Né? Please, guys, do like, share. Your engagement, guys, will be very, very helpful to grow the channel. Thank you very much.